Hilti is a global business. It has around 30,000 employees active in over 120 countries. It was founded in 1941 and obtained its first patent in 1948 in relation to fastening technology. It grew in the 1950s, launching hand drive tools and actuated nail guns, and in the 60s moved into pneumatic hammer drills and mechanical anchor systems. And during the 2000s started to change and consider standardized business processes and data. And its aim was to provide solutions for the professional construction industry. So it aims to have market leadership by offering products, services, and software that provide superior productivity and safety to its customers. So we're going to look now at one of the specific use cases of Hilti that supports this market leadership.
So, following Russell, let's first take a glance at what the patents that we have. Then we're trying to figure out what is the use case behind the patent. The patent that we have, it's the method for operating the bolt setting device. The device, so you can find the picture of the device in the right side. And so from the abstract, we can know that it's not about the driver itself, but has a monitoring and a diagnostic device, so which means there are some additional function about the device. And about the object of the invention is to increase the safety of the operation. And yes, it's a very vague description of the object. And then we take a look at the independent claim, trying to figure out what is the patent trying to protect. And yes, I skip, the preambles because it's describing the very generic device. But what is interesting here, it's about the keywords monitoring the operating data from the electric driving motor and about the speed and the current position of the actuator of a tensioning mechanism. So this is the key indicator of the functioning of the device here. And after knowing the patents and the use case that we identify here, we think the essence of the patent is about the diagnostic. And when we get the data from the sensors into a diagnostic system or software, then we have to transfer the data through the connectivity ways by USB or Wi-Fi or whatever functions that what is available for the moment. And the aim is to increase the comfortability and the safety of the operators. And following this logic, the first thing is about the networking and the digitalization, which means about the intelligent resource management regarding to tool tracking and the measuring device and about data delivering extra. And the second thing is about the system and the complete solution, and it's about the modular system. Here is something describing a Lego tool, which means we break down like what we learned from the cell methodology is to forward integration and a backward integration to make teleservice to our clients and to offer excellent experience to our customer. And then with all the data, we see the machine individualized optimization, which means we can increase the productivity and the case of use regarding to the country that where our clients are, regarding to their experience and their habits to adjust our products. And in the end is to improve, to guarantee the health and the safety of the workers and operators who is using our tools. And then and most of the important we can offer them is case-by-case maintenance is mainly performed by the independent providers. And then Russell will give us a tour about the other similar patents.
Thank you. So if we look across the Hilti patent portfolio, we can see that there is several patent applications and patents in relation to connectivity and maintenance. In particular, there's patent documents concerned with monitoring currents in welding apparatus to detect the optimal functioning of the product, to monitor electrical activity in batteries to detect a loss in performance, and further applications and patents to measure and monitor the environment around the tool to allow the optimal functioning of the tool, or in fact to monitor connections between tools to ensure that they're all operating to provide an optimal functioning of the tool. So in essence, we see that there's many patent rights in relation to diagnostics and monitoring that support models such as predictive maintenance, optimized function, and decreased downtime that all underpin the overall customer experience of decreased user frustration. So Rodrigo will now discuss how some of this customer experience is also provided by alternative intellectual property rights.
To protect the exclusivity of the functionality operating system product technology, such as the method for operation of the device, the company can and must resort to certain strategies that include property rights, such as trademark, design rights, and patents. Related to the aforementioned products, in terms of intellectual property protection and trademark, the Hilti brand and its product portfolio must be taken into account with a recognizing brand. We understand a recognizing brand to be one that's enjoying a prestige and guarantee consumer safety, according to the Convention of Paris. The Paris Agreement will protect the Hilti brand and its products portfolio in several countries, according to its characteristics of notoriety in its commercial category. Additionally, the European case, the Court of Justice of the European Community has ruled on this issue as accepting the existence of these international well-known marks. In the General Motors judgment, in which has criteria, it is subjective that the accurate public is point out that the authorities require a certain degree of knowledge with the public, which must be concerned with the brand. That is that the consumer of Hilti service will be the ones who point out that it is a notorious brand. Specifically, the method for operation of all system device, this will be international protected associated with Hilti through trademark. In conclusion, we could point out that the Hilti brand is protected international means laws in the event that the third party part or company try to develop a product or service with a similar characteristic, seeking to confuse the consumer. Erica, back to continue it.
Okay, so in terms of other forms of protection for this use case, we have the possibility of industrial design rights for the appearance of the tools, for the visible appearance of the tool with which the bolt setting method is used. We can also use design rights for the graphical user interface of the app. We could look to copyright protection for the instructions and user guide for the tool. Any original graphical elements on the tool which could be treated as artistic works could also be protected by copyright protection. Also, any original artistic elements of the graphical user interface in the app and the software utilized for the bolting process, diagnosis, and connectivity with customers. We can also look to trade secrets to protect any algorithms utilized in the bolting process and any processes not covered by any patent claims. And finally, database protection for customer lists and data gathered from the diagnostic procedures. And I will now turn over to Astrid.
Yes, so basically, if we broadly consider our use case to be predictive maintenance or predictive analytics, so what are sort of the kind of other areas that we could think of expanding our use case to and create other business models? So first, there is sort of the area of digital twins and augmented analytics. So we could also use machine learning and AI algorithms to improve on the maintenance, repair, and analytics of our devices. We could also generate software that sort of would model that as a digital twin, so have an application there. Then obviously in terms of digital identity, it will be quite interesting to also think about this sort of machine-to-machine use cases, especially since you might know that the number of IoT-enabled devices has actually already surpassed the number of people living on this planet. So it is really a very important topic. And this could be used to also sort of create automatic order for spare parts or automated scheduling for maintenance or repair of these types of devices. Then we could also employ blockchain technology to sort of create per-use business models. So it's not always necessary to sort of monitor devices 24/7. So you could determine kind of scheduling regime that sort of makes sense for your particular device. It could be daily, weekly, monthly, whatever. And obviously it is also about data sharing to make sure where data is going to, and again, improve other models. And also on top of it, it could be used to increase the security of the whole system if set up properly. And then we could also think about specific sensors that we could build for this IoT or industrial IoT use cases, and that would also give us more improved sensitivity and specificity for the maintenance, and also obviously would go hand in hand with the application of an app. In terms of protecting such use cases, I mean, there is no really one size fits all here. Obviously, everything that concerns softwares or source code or object code would be automatically protected by copyright and does not require any further registration. However, it is arguably a weaker right than the other intellectual property rights out there. So we would probably be looking at the combination of patents and trade secrets depending on the particular let's say application architecture on hand. And my colleague Christine will now walk through a more specific example.
Thank you, Astrid. So in this case, what we've now done is really try to put ourselves in the shoes of the typical user of this device, and what will they want? Essentially, they want to put all the holes in the wall with their bolts, and they want to go home at the end of the day knowing that they've finished with all those holes. So we looked at a design thinking method using the AEIOU method. We didn't do a full scenario examination. We focused on areas where a typical user may struggle. So we defined the activities, the environment, the interaction with the user, the object, on the left-hand side, you see there, the user, the potential invention, and also potential IP that would then cover that. So in this case, we identified the consumables that could potentially be a source of great irritation for somebody on a site, a user who would be using this device. The environment, they'd be on that site, it might be dirty, they'll have some gloves on, it might even be cramped, They would have had to carry a lot of equipment to where they will be going and using the device. And so they will have to have the device, the user will interact with that device to refill the magazine. And there's an insert of the figure 1 of the actual patent that we dealt with. And number 3 is the magazine where you can refill bolts into that. So nobody wants to really use individual bolts with their gloves and refill. They want it quite easy. So the user wants to refill very quickly, and more than likely they will be refilling it during use. So the potential for inventions there is twofold almost. You could have a preloaded, separately sold cartridge with a defined quantity that you could insert into the magazine, number 3 on that figure. Another invention related to the consumable is to link the sensors that would be determining what's going on with that device to count and to prompt maybe an app to order more pre-filled cartridges. So in that sense, there are a number of potential IP or exclusivity positions that one could come up with. One could think about a separate patent claim to a removable cartridge as a separately sold product. And then how would you order that? You could link the sensors to the app and a counter for determining how many times the bolts have been fired. And of course, the app would then lead you to a number of different types of IP protection, for example, copyright, design, the trademarks. And depending on how you draft a patent, you may be able to come up with a patent, but of course you need to be very careful on third-party patent rights. Then in the last column, there's a mention of managing error messages. So again, we've looked at the environment, it's a similar environment. What do you do as a user when the machine stops working? Maybe you get a beep that it's warning you to stop using the device. And in that situation, you would like an immediate solution. You don't want to have to go back to the site office. You don't want to have to stop working for the day and figure it out and come back the next day to put more holes in the wall. So in that situation, we thought that it might be useful to have an app which could troubleshoot your specific problems. So in other words, you immediately take out your smartphone, which you have in your pocket. You have a look to see what the sensor would be telling you, what the beeps mean, and help you to troubleshoot that on your own. But if there's something that you cannot fix on your own, perhaps to call a Hilti service technician to help you troubleshoot. And it may be that Hilti service technician determines that actually you can't use that device anymore, you need to order a new one. They can immediately solve the problem. So all of this in the use case will lead to increased productivity. The predictive maintenance element is there, and that can all be achieved in your app, which you can protect with copyright, design, trademarks, and hopefully a patent in the methods. And what is nice about the fact that we are last in all of these 4 presentations is it's a wonderful example of how all of these patents together can create great synergies for expanding on many of the use cases that are involved. Thank you very much.